there's a few things which differentiate reinforcement learning from supervised learning and from unsupervised learning as well. And so let's just see if we can understand those distinctions. So the first one is maybe the most obvious, that there's no supervisor. When we do reinforcement learning, no one tells us the right action to take. Instead, it's a trial and error paradigm. There's no supervisor. There's just this reward signal saying, you know, that was good, or that was bad, or that was worth 3 points, or that was worth minus 10 points. No one actually says that was the best thing to do that action in this situation. So there's no supervisor. The second major distinction is that when you get that feedback saying good or bad, it doesn't come instantaneously. It may be delayed by many steps. So in the reinforcement learning paradigm, you make a decision now, and it may be, you know, many, many steps later that you actually see whether that was a good decision or a bad decision as the kind of the decisions that you may unfold over time, and it may be that it's only retrospectively that you realize that was a bad decision, because at the time it looked like it was very good, and maybe even you got positive rewards for several steps before some catastrophic large negative reward. So in RL, the feedback is delayed, and that makes it very different again. Furthermore, time really matters in RL. So we're talking about sequential processes, sequential decision-making processes, where one step after another, the agent gets to make decisions, pick actions, see how much reward the agent gets, and then optimize those rewards to get the best possible outcomes. So we're not talking about IID data here. We're not talking about the classical supervised or unsupervised learning settings where you get some IID data set and you just get to learn on that data set. Here, we've got a dynamic system. There's an agent moving through a world, and you know, imagine a robot sitting, you know, walking through some environment. What that robot sees at 1 second is going to be very correlated to what it sees at the next second. This doesn't really, the IID paradigm that we're familiar with doesn't apply to RL. And specifically, perhaps the most important way in which IID breaks down is that in reinforcement learning, the agent gets to take actions. It gets to influence its environment. It gets to move around. You know, imagine this robot. It gets to move around in its robot. You know, if I'm in the robot and I walk to this side of the room, I will receive very different data. So I'll see different things. I'll get different rewards to if I'd moved over to this side of the room. So the agent is actually influencing the data that it sees.